Okay, here's the second part of the 6-4 video, and these are your solutions to your U-tries. So here's the final solution, and here's my steps. You can feel free to pause, but I'm going to go through this kind of quickly. When I see that 2 out in front of the log, that reminds me I have the power rule happening. So my first step was I put my 2 up here as a squared and here as a squared. So now I'm here, and then when I see the subtraction, I know I can combine those into a single log and make it x squared over 6 squared, right? These are what I'm taking the log of. And now here I have log on both sides with the equal sign in the middle. That makes me happy. I can ignore the logs and set my x squared over 6 squared equal to 24. And then I just want to solve, so I multiplied both sides by 6 squared. And then I get x squared equals 864. So I want to square root both sides. And then the second power and the second root undo each other, and I'm left with this. X equals plus or minus square root of 864. I thought for sure it would be a perfect square, but it wasn't. So I did a tree over here. Noticed I started my tree using these 2 numbers that I knew multiplied to get me 864. I got double 6's here and double 2's here, so a 2 broke out and a 6 broke out, so I had 12 outside the jail and 6 inside. Okay, the second one I have plus. Don't have any numbers out in front, so I don't have power rule on this one, so this would just be product rule. So I can combine them into a single log of x times x minus 6. I don't have logs on both sides, so I have to convert this to an exponential. And that's what I have here. 2 to the 4th equals x times x minus 6. Distribute here. X squared minus 6x. 2 to the 4th is 16. Minus 16 from both sides. And there's my quadratic that I need to solve. Luckily, it's factorable, right? I'd have negative 16 and negative 6 here. So that would be negative 8 and 2. So there's my factoring, and there's my solutions. So that is it for 6-4. Things that you want to remember is your goal is to combine these 2 separate logs in all these cases into a single log. So you want a single log because that helps you in solving. So for all of these, your goal is to get a single log like we did in these examples. So then you can either, if you have logs on both sides, ignore your logs, or if you don't have logs on both sides, then convert it to an exponential.